And again, the heart of this is the hum functor. So the hum functor is actually, in general, it gives us glimpses of a much bigger beast, or much more interesting beast yet, called the hum profunctor. But it's of this form. And the dash here means fill it in. Just consider it as filled in. Remember, that's where we're going to fill in its arguments, its possibilities. So A is going to be fixed here. We're going to have a hum functor, call it H sub A, or Y sub A for Yoneda, called C of A comma dash. Okay. And basically, this is going to be a functor. So it's going to map for each object, A, B, C. It's going to map it to a set. So for object B, it's going to map it to the set of C, A, comma, B. That's going to be a set. What is it going to be a set of? Of what is it going to be a set? It's a set of morphisms, right? So here's our category C on the left. Here is set, and I'm showing each object maps over in set. Are we okay with this? So here B maps to C, A, comma, B. And let's go see what those are. Well, there's going from A to B, there's J, H, and G. So C, A, comma, B will be the set J, H, and G, the set of morphisms from A to B. Are we okay with that? So the hum profunctor, remember, it maps as, the hum functor, as a functor, it maps objects to objects and morphisms to morphisms. And so it maps each of these objects in C into a morphism in set, which is, what's a morphism in set? It's a what? What's a morphism? Oh, sorry. Yes, it maps objects in C into objects in set. And what's an object in set? An object in set is a set. It's a set. Yeah, that jumped the gun. As a functor, it maps objects to objects here from C to objects in set, which are sets. So B, the object B gets mapped into the set CAB, which is J, H, and G, right? It's the set of hums from A to that. We have A is fixed here. It's the fixed observer here. And we're considering for a given object kind of what that object looks like from B, all the morphism from A rather, all the morphisms from A to it. Are we okay with that idea? So each object, we're going to see what it looks like from A, all the morphisms from A to it. So B, it's J, the set JHG. C, it's the set F. It's just the names of each of these morphisms, right? F after J, F after H, F after G. Okay, take those as names for now. They're actually the composite of this and each of these. Remember, every pair of n-10 morphisms have to have a composite. So there must be some composite of F and J. And that's this one here, I'm telling you. F and H has a composite, this one, F and G has a composite. So this object is mapped over to the set F after J, that's the name of this morphism, F after H, this morphism, F after G, this morphism. If you told me this morphism was named cat, I'd tell you then this is a set of cat and these other two, right? So I'm just giving these names. So a functor maps objects to objects. Are we okay with how these map these objects? Mapped an object in C. For each object in C, we have an object in set, a set of these. Are we okay with that? What does it map CAA, or what is this map A to? What does the functor map A to? To what object over in set? Maps objects to objects. So objects in C, there's an object called A. It maps that to an object in set, which is a set. What is that set? Identity. Are we okay with that? Okay. And now a functor does more than map objects to objects. It maps what to what? What else does a functor map? That's much more interesting mapping object, or the mapping object. It maps morphisms. Good. So for each morphism, it's going to map it over here. How does it map it? Well, it maps it in a quite interesting way. We're going to see this. Okay, here we go. So it's going to turn each morphism here into a morphism in set. What's a morphism in set? Begins with F, function, right? It's a function from a set to a set. Are we okay with that? Okay, so this CAJ, you'll notice that may confuse you because we will have seen this notation CA comma B, for example, or CA comma C only for objects previously. But I'm telling you, we can apply this for morphisms, or instead of having an object here, we can have a morphism. And it's indicating how the functor acts on morphisms, how it lifts morphism, how it maps that morphism. So let's go see how that plays out here. How does it map those morphisms? Well, there's a beautiful logic to it. We're going to see how it maps each of these morphisms. So let's take a morphism from A to B and see how it maps J. Are we okay with this? Okay. So first of all, we know that wherever it maps this morphism over here in set, it has to map it to something that goes from where it mapped the set where it mapped A, that's the source of J, to the set where it mapped B, right? Are we okay with this? So it has to map it from the set, right? The morphism, when the functor acts on morphisms, it maps it over to go from the image of its source, the image of A, the set to which it mapped A, to the image of B, where the functor mapped B. That's where this morphism has to go. Do we see that? Okay. And we're going to call it CAJ. And what I'm going to tell you is that that's a function. What is that function going to do? It's going to do something. Its job in life is going to take each of these members of this set. What are the members of this set? It's identity alone. And it's going to post-compose it with this, okay? This is a morphism. So it's going to post-compose it with J in C and get back a result, J. So that's going to be J. In other words, in C, identity A post-composed with its second argument here, J, is what is the composition of identity with J over here? If I told you in C, you compose identity with J, what would you get? J, right? You compose identity with anything in C, going out of it, you get that other thing back. Are we okay with that? So this is J. I'm telling you CAH is post-composition of H after identity here. And what is post-composition of H after identity? H. Are we okay with that? And post-composition of G with identity is G. Now, that may strike you as very weird, but it translates this set. It's a function. This is a function that translates this set into this set. For each element of the function, we have to give an element here given, some morphism. And I tell you the rule that this function is going to use, it's going to take the thing you're given here, J, and for each element here, it's going to post-compose it with that element in J, in C rather, to get the result. So this is a function from this set to this set. Do you see that? Okay, the more interesting one, and I told you this is kind of like the view of B from A. J, H, G. It's like we're in A and we're looking at B and we see it J, H, G. This is kind of like our line of sight to B. Okay, now let's consider this one here. I should note, probably before we go on to it, it's the same rule for this one. Each of these, if we want to see from A to C, all we do is we have a function. Remember, functions are mapped to functions. So if we lift F J F after J, it has to map, this morphism have to map to a function. What function is it? It takes each argument here and it post-composes it with F after J. And that's going to give us, in this case, F after J. And so what I'm saying is that that is going to map, it's going to map this identity A to F after J, right? A function maps each of these into one of these. And I'm telling you, this function, Cij, maps each of these, which is just one, into J. This function maps each of these into H. This function maps each of these into G. This function maps each of these into F after J. This function maps each of these into F after H and F after G. And I'm saying this is the view of C from A. Are we okay with that? It's kind of the line of sight. Okay, now let's consider what it does with this. This is where it gets particularly cool. Okay, C, A, comma, F. See where F is over here? It goes from B to C. We're going to lift this morphism to be a morphism in set. That's what a functor does. It maps morphisms to morphisms. Morphisms in the source category in the domain are mapped to morphisms in the target category on the codomain. And a morphism in the codomain here is a function. What is this function's job in life? Well, its job in life is to translate the source set to the target set. This function maps from a set here to a set here. It maps, watch my words very carefully. It maps ways of viewing the source from A into ways of viewing the target from A. In other words, it maps, let me put it another way. This is another useful metaphor. It maps ways of getting from A to B. For each of the ways of getting from A to B via this way or this way, via G, J, H, or G. Each of the ways of getting from A to B, it turns it into a way to get from A to C through B. Do you get that point? So that's what this function's job in life is going to be. Before, it was a little bit trivial. We had to ask, for each of the ways of going from A to A, it's going to give us a way to go from A to B. Yeah, okay, fine. It's going to be, we can go with J, or we can go with G, H, or G. But now this is more interesting because we're asking for, to get from B to C, we're going to turn each of the ways of getting, to get from A to C, we want to go from A to C through B. So we're going to take each of the ways from going A to B, that's what these are, and we're going to turn them into ways of going to A to C. Each of these ways of going from A to B, J, is a way from going from A to B. Do you agree with that? H is a way of going from A to B. Do you agree with that? Over in this source category, C. It's a way of going from A to B. H or G, H and G are ways of going from A to B as well. And for each of those ways we can go from A to B, we're going to extend it by F to have a way of going from A to C through B. Do you get that point? And so J is going to map into F after J. What is F after J in this category, source category? Well, it's F after J. It's the one we called cat sometimes, right? We could have called it any other thing. We could have called it, and Larissa's on our elephant, right? These are ways of going from A to B. Let's take H. If we go from A to B with H, we can post-compose it with F. We can take F after H to get a way of going from A to C through B, which is boom, boom. And what is that way? It's F after H. So what this hum functor is doing on objects is for a given object. So if it's a hum functor on A, it's turning each object in C. This is the hum functor for C, category C. That's why our attention is on C. The hum functor is going to be mapping over to category set in a very particular way. The hum functor for C from the perspective of A is going to turn each object of C into a way of going from A to that object, ways of going from A to that object, or ways of seeing that object from A. Both are good metaphors. The hum functor on morphisms is going to turn each morphism into a function between those sets. So the hum functor on a morphism F going from B to C is going to turn ways of going from A to B, the source of the F, to ways of going from A to C, the target of F. That's what its job in life is. That's going to be a function, right? Remember, functors in general from C to set are going to turn objects into sets, ways of going here from A to that object here. And a functor from a category to set is going to turn morphisms in that category into functions between those sets. And specifically, it's going to turn morphisms. It's going to turn this into a morphism that knows how to, for each way to go from the source of that morphism in C, B, from A to B, to a way to go from A to C. And that's what this is. That's what this function does. For each of these, it turns it into, each of these ways going from A to B, it turns it into a way to go from A to C. Are you comfortable with that? And that's what a hum functor does. A hum functor's job in life is given by the category for which it is the hum functor and for particular object at hum functor A. This hum functor is specific to A. In fact, A as the source here, sort of vantage point from which we see other things, or the way, the place where we start our journey. Now, I want you to note something. So this treatment was, by the way, is inspired by Bartosz Miliuszki's treatment of it, and I'd recommend it, and his wonderful series on category theory for programmers. But I do want to emphasize something that he also emphasizes with hum functors. So we call this a representable functor, in large part, in significant part, because all we need to know to specify this entire functor for C, if we know we're dealing with C, all we need to do is to say from what object we start, A. And I have an entire functor specified, right? If you tell me, if I tell you I want to know the hum functor from B, that entirely gives you the information you need to specify that functor. What each object is mapped to, what each morphism is mapped to, right? That's pretty powerful. Like one piece of information, the starting point in a given category, gives you enough information to specify a whole functor, what each object maps to, what each morphism maps to as the function. So that's pretty powerful. I will note that the hum functor preserves structure. It's a function. It honors composites. And I won't show this here, but it will honor composites. And I will further say, and unfortunately I don't have I will say there's a contravariant version of it, which is not so the covariant version, the version we've been looking at, C A comma dash, is turning each object into ways of getting to that object from A. And each morphism into from say X to Y into ways of getting from A to X to ways of getting from A to Y. But here we are instead the contravariant version, C dash comma A, for each, for a given A, we're going to map each object into ways of going from that object to A. Going to A, right? This is just like CAB or CAC is ways of going from A to C. This is where it's going to where it's going, right? Whither it goes. And it's going to turn each morphism into, from say C to B, into ways of going from C to A to ways of going from B to A. Are we okay with that? And I happen to have drawn it in sort of the verse now where B goes from, we have arrows from B to A. But the idea here is that we have it's the dual, so we have the reverse view of the world. We're concerned about ways of seeing A from different objects and translating a way of seeing it from B to a way, or from C to a way of viewing it from B, or how to get for each object from there to A, and turning morphisms from a given object X to a given object Y, or from a given object C to B, into ways of getting from C to A to ways of getting from B to A. This is the contravariant version of this. And you'll notice it's contravariant, and it turns out that it has the reversed arrows associated with it. We're trying to get to A from places, and that's the logic of kind of wayfinding, and I'm glad to expound on a separate session. Okay, so these are representable functors. I do want to just note, and I think some people here are aware, and this is going to be, we're not going to be able to cover this now because we have to talk about pre-sheaves. But I will just say that rather than confusing you with diagrams, I'm just going to say representable functors are the building blocks we use for pre-sheaves. Pre-sheaves are going to be functors from C into set, and the representable functors are the Lego pieces. Or a better analogy yet is they're going to be the Tinker Toy pieces out of which we can build any function from C to set. These are the building blocks, the representables, which are either these hum functors, these sort, or things that are isomorphic to them. Functors isomorphic to them. And there's some discussion of that in the book of sort of isomorphisms here. Okay. Are we okay with this?
You could go back to the contravariant.
Contravariant, yeah, yeah. Yeah. Okay. So here we have C. You notice to make this concrete and more interesting, I have these arrows reversed here in C. So what's going on here is we're considering ways for each object is turned into ways of getting from that object. A set, it's mapped to a set. And what is that set? It's ways of getting from the object it's mapping to A. So A gets mapped to the only way of getting from A to A, which is identity. B is mapped to the ways of getting from B to A. What are they? They're J, H, G. You can go this way, or this way over here. In C, we're asked about ways of getting in C from things to A. So each object, so this object turns into ways of getting from B to A. Object C gets turned into a set. What is that set? It's ways of getting from C to A, again, in category C. Just these. But the really interesting thing is what turns F into. And the important thing here about it being contravariant is that this F, when you map it over, it is flipped. See that? See that? It flips it. And there's a totally sensible reason for this. And I'm glad to explain it. But outside of this particular session of the class, I will just note that F here goes from, in C, goes from C to B. So when we map it with the functor, this is contravariant, it's in this called negative position here. And there's a totally sensible way to understand this, but it goes in the opposite way. And let me give you some motivation for this here. So functor F goes from C to B in C, in category C. Do you see that? Goes from C to B. And what I'm saying is, if you want to know how to go from here, from C to A, if you want to know in this category, capital C, how to go from C to A, and you already know how to go from B to A, what I'm saying is that what you need to know from category C is how to go from C to B. Saying if Mehdi told me, if I say I really want to get from here, Sphinx, to Place Riel, and I'm new to campus, and Mehdi were to say, well, Nate, do you know how to get from the front of Thorvaldsen to Place Riel? And I say, yeah, I know how to, that's B. I want to know how to get from Sphinx to A, and I don't know how to do it. And Mehdi says, well, look, do you know how to get, Nate, do you know, Mehdi says, I have a class shortly after this, but do you know, Nate, do you know how to get from the front of Thorvaldsen to Place Riel? I said, yeah, I know how to do that. And Mehdi says, I will take you from Sphinx to the front of Thorvaldsen, and then you can go. That would be fine, right? It would let me get to Place Riel, right? And the point is that I need this F to go from C to B, not from B to C. My problem is not, I want to go from the front of Thorvaldsen to Sphinx. No, the problem is I want to go from Sphinx to the front of Thorvaldsen in order to know how to get, and then, I know how to get from the front of Thorvaldsen to Place Riel. That will let me go from Sphinx to Place Riel. So what I'm saying is here, if we consider these things, that's what I actually need here to know how to go from the set of ways going from Place Riel to the bus terminal, to turn those into the set of ways going from Sphinx to the bus terminal. I need to know this arrow actually in this direction. It wouldn't help if I knew how to go from front of Thorvaldsen to Sphinx. That's not going to be helpful for me. If for Mehdi to tell you, I'll tell you how to go from the front of Thorvaldsen to Sphinx, I'd say no. I want to go from the front of from Sphinx to the front of Thorvaldsen, because from there I can go to Place Riel. That's what I'm saying I need. I need an arrow in this direction to go from knowing how to go from the front of Sphinx to Place Riel to, for each one of those ways, to go from a way to go from Sphinx to Place Riel. This is the key arrow directionality I need from Sphinx to Thorvaldsen front. So that's why this is in a flipped direction. It will let me, if I know how to go from Sphinx to the front of Thorvaldsen, that will let me go from ways to go from Sphinx to the Place Riel, to the bus terminal, to go turn each of those ways into a way to go from Sphinx to Place Riel. That's what this translation makes possible. And you notice it's flipped, right? Like here, I'm going, mark my words. I'm reasoning about ways for each way of going from Sphinx to the front of Thorvaldsen. I get a way of going from the front of Thorvaldsen to Place Riel into the Sphinx to the Place Riel. So here I'm in the source category, I'm going from C to B. Here I'm translating CB, A to CC, A. It's in the reverse, right? It's going B to C here. You see that? You see that? CB, A, that's a set. To CC, A, this is kind of B to C, even though this is C to B. You see that? It's in the reverse direction. That's why I'm saying it's contravariant. This arrow gets flipped around here. And that's the nature of getting from places to a destination. It goes the opposite direction. And contravariance is very sensible if you start to understand it like that. It's like, I don't have this information, I need this information. And so what helps me is knowing how to go from Sphinx to the front of Thorvaldsen. Lets me translate ways of going from the front of Thorvaldsen to Place Riel to ways of going from Sphinx to Place Riel. Are we okay with that? With the contravariant version? Do you see why it's contravariant? Here, this arrow is flipped around. The fact that this goes from C to B lets me get something that goes from CBA to CCA. It's flipped around here. And yeah.
Does that also explain why the notation within C, A, the function letters are composed in the opposite order?
So which one?
Near the bottom right, C, A, F of J, F of H, F of G, they're in the opposite order.
Yeah, it's pre-composition. Oh, yeah, this should actually this is a mistake. This should be this one right here. No, this is correct. It's X after. Oh, okay. Yeah. These should be, sorry, there is a mistake. It's a mistake in the wrong place. You'll notice with the covariant version, these were F after G X, right? Like here we're considering ways of going from A to B, and we're translating each of those ways going from A to B into ways going from A to C, right? And so for each way to go from A to B, we post-compose it. We take it, and then we go via F to get this way. Are we good with that? But here, we're going in the opposite direction. In other words, we're kind of pulling things back. So here we want to go from the front of Thorvaldsen, so from B to A. That's these things. And what we need to do is we need to from B to A, and then we need to take F before them. In other words, we need to do F and then J to go from to go from Sphinx through the front of Thorvaldsen to this. For each of these ways, we can go to front of Thorvaldsen to Place Real. I now have a way of going from Sphinx to Place Real. So this should be J after F.
I mean, like the X.
This is correct. This is correct. This is not correct. This needs to be.
That was getting me.
I'm terribly sorry. Yeah. This is F. Okay. The sort of the not very nice way to do it, but I'm just going to do it right now as a fix up. Is this should be. I'll fix it properly and afterwards. F and then J. Wait a minute. F and then J H or F and then G, right? It's really this set. First I do F and then I do J, and that gives me a way of going from C through B to A. Are we okay with that? Is that clearer? Yeah, apologies. That's a terrible thing. I inflicted an injury on you folks. And I'll clean that up. Yeah.
If you have a shortcut from C to A, from C to A, a shortcut. For example,
If there were shortcut not through B, for example. Yeah. So that would be fine. There could be ways of like going here, things here from C to A, which are not composites of, like, there could be one way of going C to A. So to be clear, what is required is that for each end pair of end-to-end arrows, there must be a morphism here, right? It could be the same morphism, but there has to be a morphism. But there could be some morphisms here that are not composites of these, right? That's like Mehdi's shortcut idea. And that would be fine. Maybe we call it W for wild card or whatever, wildcat, the hang glider method or something like that from Sphinx to Place Real. Yeah, exactly. What was that game in Harry Potter where they fly around on brooms or whatever? Quidditch, yeah. The Quidditch method. So you can fly there. Cute. So there could be a method of doing that, right? And then, Mehdi, each of these would give a method here. It would map into some one of these. But so each of these would be mapped into a way of going from this, in other words, a way of going like that and that and that. But then there'd be some here which would not, right? And this map from this set to this set, those other ones that are from the Quidditch or the hang glider method or the underground shortcut tunnel method or whatever, those would be ones not in the image of this function, right? It would be like things not reached through B. There are ways of going directly via the, fireman's pole to the sub-basement and then the tunnel over to Place Real, right? Are we okay with that?
So C, A doesn't have to include transitions through B. It just has to include ways.
That's right.
To get from C.
That's right. But for F, for each of these arrows from C to B. There is a way of translating away from going from B to A to a way of going from C to A. It's just that, and that yields a function from ways of going from B to A to ways of going from from C to A. But there can be other ways of going from C to A. Are we good with that?
If there's any method that goes through any other.
Yeah.
Object in set, in this case, then it's going to include.
That's right. That's right. These are great questions. Wonderful question. Other questions on this? I'm tempted to show you why, like, contravariance has, like, we use it all the time in our daily life and we never think about it. But first, I want to answer a question about this particular thing, and then maybe I'll show that. I have some slides that I think might be helpful. They were helpful for me to think it through. Are we okay with this? Can I show you this other stuff from contravariance? Could I show that to you? Okay. Okay. Okay, it turns out this is really practical. It comes up in programming, it comes up in reasoning about daily life. And it turns out it's supernatural. It's supernatural. It's not how I wanted to phrase it. It's like incredibly natural. Okay. So let me give you, I prepared a bunch of different examples where we use this. Okay. So let me give at least the first. Okay. Okay. So suppose you have a recipe. You're going to make some food. You have a way of turning chopped tomatoes. You have some recipe that tells you how to turn chopped tomatoes, sliced cilantro, and extracted egg whites. Okay. We're going to call this C. Into a whole omelet. We're going to call it A. So we have a map from C to A, from going from these ingredients to a whole omelet, call it A. So it's a map from C to A. Are we okay with that idea? So we have some way of turning C's into A's. Okay. And we're looking to create a recipe that takes this thing here, the same starting ingredients, the same ones, type C, into a fancier omelet where we'll cross-slice it and we'll put sriracha sauce on this hot sauce on. Okay, we'll call that type B. Are we okay with this idea? So we're going to have the same recipe, but instead of getting an omelet, we want to have it in that omelet, but we want to do some spiffing of it up. We want to kind of we want to soup it up. We want to sort of slice it up and put some sauce on it and so on. Call it C to B. Okay. So tell me, I mean, just intuitively, what do we need here? And I'm going to give you two choices. Do we need a way from going A to B or a way from going B to A? Okay. So in other words, do we need A to B will be a way of turning a whole omelet into a cross-slice omelet with sriracha sauce. In other words, a way of taking an omelet and slicing it up and putting sriracha sauce. Will that get us what we want to be able to turn these ingredients into a cross-slice omelet with sriracha sauce? Or is what we need a way of turning a cross-slice omelet with sriracha sauce into a whole omelet? Which was the one we want? Just common sense. The first one, right? We want to, look, we know how to turn this into an omelet, and we just need to know how to cross-slice an omelet and put sriracha sauce on it, right? Are we okay with that? So what we need is, think of this as function composition. We have this, right? We want this. All we need to do, this is the one we know, all we need to do is to do F post-compose with it. Post-compose with that. Put F after this to get a cross-slice omelet with sriracha sauce, right? Are we comfortable with this? This is covariant. This is, we nothing fancy. We just post-compose it with this. just like way back. Okay, sorry. Way back here. Oh no. Okay, here we post compose with F. We do F after that. Okay. And what I'm going to say is we're going to here. This, so I'm saying this is what we want. And what I'm telling you is that we're going to now examine a case of where we have the contravariant need, okay? And this is what we're going to do. Okay. This is the co-example for this example 0. Co-example for this. Okay, so here we're going to have the same starting ingredients, but now and so we have the same recipe. Same recipe starts the same starting ingredients, and we turn it into a whole omelet just like before. It's the same recipe we were doing this before we reason about how to do something fancy at the end. And now we want to figure out, okay, wait a minute. This recipe calls for chopped tomatoes, sliced cilantro, extracted egg whites. All we have are whole tomatoes, fresh cilantro, not sliced yet, whole eggs. We're going to call this type B. So in other words, we have a way from going from A to C, just, excuse me. Yeah, so we have a way from going from this, we're going to call it A, into a whole omelet, call it C. And we want to go instead start with something different. We want to start with something that's upstream, whole tomatoes, fresh cilantro, whole eggs, and produce the omelet. What do we need to do here? I mean, again, common sense. Is what we need to do a way of turning chopped tomatoes into whole tomatoes? Way of turning sliced cilantro into fresh cilantro and egg whites into whole eggs? Is that what we need? Or instead, do we need a way of turning whole tomatoes into chopped tomatoes, fresh cilantro into sliced cilantro, whole eggs into egg whites? Which is the one we need? What's that?
The latter.
The latter, right? If this is our recipe, in our brains, we just know, like, okay, this recipe calls for chopped tomatoes. I don't have chopped tomatoes in front of me. All I have is whole tomatoes, but I can turn whole tomatoes into chopped tomatoes, right? We okay with that? So we have this recipe. We want to be able to do that. And what I'm telling you is that what we want to do is to actually have something that turns into an A. It targets A. It's not that we want, so we want something that goes from B to A, even though this is from A to C. In order to get something from B to C, we pre-compose it by this way of turning whole tomatoes and chopped tomatoes, fresh cilantro into sliced cilantro, whole eggs into egg whites. So here, if we have something that's from A to C, and we want something from B to C, what we actually need to do is pre-compose by something that goes from B to A, not from A to B. That's not going to help us. A way of going from egg whites into whole eggs is not going to help us. What we want is going from whole eggs to egg whites. We want to go produce this thing that we need to start with to produce them. And you'll notice that it's in the opposite direction of what you might think you need, right? So here you have this. We want this. We want to go from like something that starts with A to something that starts instead with B. But we do that by having something that turns a B into an A. Do you see that? Do you see this, EJ?
Yeah, but we will have a meeting from 12 to 1, right?
Actually, it turns out I'm gonna have to rearrange that, but, yeah. Okay. So what I'm trying to say is this is actually contravariant in the same sense, like we have something goes from A to C. We want something goes from B to C, but we're not going to get that by having something goes from A to B. We're going to get that by having something goes from B to A. And that may seem counterintuitive at first glance. Like if you write down the notation, that wait a minute, we have something goes A to C. Of course, if we want to get something B to C, we have to turn A's into B's. No, we have to turn B's into A's because we're starting with an A. And we want to turn, and we want to start even further upstream than A. We want to start with a B that we can then turn into an A. Because we need to get to this point from something upstream. Okay, so you might think, wait a minute, we want to go, I'm going to put this on the board, and I'm going to turn this here so those remotely can have a chance of seeing it. We have something that goes from A to C, and we want to map that. This is our recipe. We want to map that to something. We want to have this thing, but we want to turn it into something that lets us go from A to C. This is our whole omelet. This is our sliced tomatoes, egg whites, sliced cilantro. And we want to turn it into something that goes from B to C. This is like our whole tomatoes, fresh cilantro, and whole eggs, right? And I'm saying we want to turn this into this. And you might think, oh, well, all we need that is to have something that goes from A to B, but we'd be wrong. What we actually need is something that goes from B to A, because if we have this, we know how to get a C out of an A, then what we need to do to start with a B and get a C is we need to turn B's into A's. And then we're golden. Then we're all fine. We have a way from going A to C. We want to have a way of going from B to C. If I can just go from a B to A, then I'm all set. If Mehdi asked me, do you know how to go from the front of Thorvaldsen to Place Real? I said, yeah, that's this. And I want to go from our current classroom to Place Real. Then what I need is not go to front of Thorvaldsen to here. I need to go from here to the front of Thorvaldsen. I need to pre-compose by B to A. And that's exactly what this contravariance is doing here. It's giving me a way from going B to A, and that lets me to have something from B to C. So it may sound counterintuitive, but it's a common thing in our mind, like as a matter of common sense, when we're seeking to get to a place. And you may remember that's what this was about, getting to a place. We're getting to A, right? And this issue didn't come up in the same way when we're starting at a place. We're starting at a place here. And we're going from there to places, just like for this example, if we're starting here and we want to go further downstream to something that's more fancy by chopping it up, it didn't come up. Here it comes up, the co-example, because we're starting upstream of it. So we have to get from here to A, and then we're all golden. Or consider it this way. We have access to a library, a programming library, that takes a text file and outputs a PDF. And we want to build a system that takes that same text file, type C, and it outputs a PNG rendering the text. Just like this. And the question is, what do we need if we want to start with this? This is our library. Which of the ones do we need? Do we need something that turns a PDF into a PNG, or something that turns a PNG into a PDF? Which do we need? PDF to PNG. And I hope this is reminding you of this sort of case. We want to go further downstream. We know of ways of going from A to B, and we want to go from A to C. And so we're going further downstream. We need ways of going from B to C. That's what we're dealing with here. And so, yes, we want a way of going from a PDF to a PNG, and then we could just compose them, post-compose with this on top of this to get something that goes from a text to a PNG. Are we comfortable with this? Now suppose instead that we have something the reverse. We have a library that takes a PDF file and outputs a text file, something like this, right? And we want to build something that takes a PNG file and outputs a text file that gives the textual contents. So we have this library. We want to get this way of turning PNGs into text. What could we do? Do we need something that turns PDFs into PNGs? Is that what we need? Or do we want something that turns a PNG into a PDF? PNG to PDF would let us then compose with this, right? Even though you might think intuitive, formally you might think, well, okay, wait, we have something at PDF to text. We want to get something that's PNG to text. So surely we have to turn a PDF into a PNG. No, we want to turn a PNG into a PDF. Are we okay with that? Okay. And so indeed, we need to turn a PNG to a PDF. And that gives us PNG to text. So we have one of these. We want to get one of these. We don't get it by turning a PDF into a PNG. No, we turn it by turning a PNG into a PDF, because we're going to consume, grab, eat a PNG, right, is what we want. And we're going to be able to do that upstream of the PDF by having a way of consuming it and giving it to this to then produce the text. Do we get that? Okay. Okay. So here's another one. Travel services. Okay, we have an existing input flight from Seattle to Calgary, and we're seeking to arrange travel from Seattle to Saskatoon. Okay. Okay. So we know we have a flight from Seattle to Calgary. We want a way going from Seattle to Saskatoon. What do we need? Do we need a way of going from Calgary to Saskatoon, or Saskatoon to Calgary? Which do we need? Calgary to Saskatoon, because we're going more downstream, right? Can I remind you again? It's just this same thing here. We're going more downstream. We're trying to get two places. We're going from A to B to go from A to C. And we do that by doing a map. It's not contravariant at all. It's post-composition. We're post-composing this with that, right? If for each way we go from A to B, we can go away to A to C. Are we good with this? Okay. So let's just finish this example. So that's exactly right. We just need a way from going from Calgary to Saskatoon. We're golden. We can go from Saskatoon from Seattle to Calgary. Are we good with that notion? Okay, now we try the co-example, right? We have a way of going from Calgary to Seattle, and we're seeking a way to go from Saskatoon upstream, right, to Seattle. What do we need? We have this. We want to go to this. Do we need a way of turning Calgary, going from Calgary to Saskatoon, or do we need a way from going from Saskatoon to Calgary? Saskatoon to Calgary, right? This is what we want. It's pre-composition, and that's exactly what we have here. It's pre-composition here. So we're pre-composing it by this. We want to get from C to A, from Saskatoon to Calgary. We have ways of, Saskatoon to Seattle. We have ways of going from Calgary to Seattle. So all we need is a way from going to Saskatoon to Calgary. It's contravariant, and you might think, well, that doesn't make sense formally. We want this, we want that. How could we possibly, how could we have this, we want that. Surely we need a way of going from Calgary to Saskatoon. No, you want a way of going from Saskatoon to Calgary because you're going to pre-compose it with this to get from Saskatoon to Seattle. And that's exactly right. Okay, I have lots of other examples, language translation, functions, and so on, but I think you get the understanding here. And this is very useful in programming as well, because this issue comes up quite a lot if you're trying to build systems or whatever. And it really depends, do you have something as a starting point that you need to do your work? Like you need to get to Calgary to do your work? You need the ingredients for your recipe? Then you're talking about pre-composing to get there. Or is it a matter you're dealing with the end product and you want to take that end product and go further downstream, in which case you're post-composing and it's covariant. Pre-composing to get to the starting point, to get to the thing that's needed. Contravariant, post-composing downstream from the product to something else, covariant. I hope that's helpful. Okay.